This is the vocabulary for lesson 10-8. Compound event consists of two or more simple events. Tree diagrams is a diagram to show the number of possible outcomes, and I have an example of a tree diagram. The fundamental counting principle, abbreviated FCP, event M can occur in M ways and is followed by the event N that can occur in N ways. Then the event M followed by N can occur in M times N ways. It's basically a shortcut. So here's an example. If you have 3 shirts, 4 pants, you would multiply 3 times 4 to give you 12, so you'd have 12 different outfits. Independent events is the outcome of one event does not affect the outcome of the other event. The example is if you have the probability of A and B, you would find the probability of A times the probability of B. Notes 10-8, probability of compound events. The objective is to find the number of outcomes for an event and find the probability of compound events. The Common Core state standards are listed in the mathematical practices. Outcomes of compound events. We're going to create a tree diagram and an organized list to find the number of outcomes for each situation. Number 1, how many sandwich combinations can be made with ham, turkey, and roast beef on white or rye bread? We'll start by identifying the ham with H, T for turkey, capital R for roast beef, W for white, and lowercase r for the rye bread. Start by listing your meats. We have ham, turkey, and roast beef. And then we want to put our types of breads. So we're going to branch them off. So we have white and rye, white and rye, white and rye. So our outcomes would be ham with white, ham with rye, turkey with white, turkey with rye, roast beef with white, and roast beef with rye. So we count up the number of outcomes, and we see that we have a total of 6 outcomes. So there are 6 different sandwich combinations using 3 types of meats and 2 types of bread. Number 2, Cheryl has a choice of a pink, red, or yellow shirt with black, gray, or tan pants. So we start with our shirt, and then we're going to branch off our pants. Let's use P for pink, R for red, Y for yellow, B for black, G for gray, and T for tan. So we start with our shirts. We have a pink shirt, a red shirt, and a yellow shirt. We branch off our types of pants. We have 3 different types of pants. We have black, gray, and tan. Branch off our 3 different types of pants, black, gray, tan. Black, gray, tan. So we're going to list our outcomes. So we would have a pink shirt with black pants, a pink shirt with gray pants, a pink shirt with tan pants. Then we have our red shirt with black pants, red shirt with gray pants, and our red shirt with tan pants. Then we have our yellow, and we'll put that off to the side. We have yellow with black, our yellow with gray, and our yellow with tan. So we count up our number of outcomes. We have 9 outcomes. Find the total number of outcomes using the fundamental counting principle. So this time we're going to use the shortcut. We don't need to do the tree diagram. A sweater comes in 3 sizes and 6 colors. So we take our number of sizes times the number of colors, so we have a total of 18 outcomes. 4, a restaurant offers dinners with a choice of each of 2 salads, 6 entrees, and 5 desserts. So we have 2, 6, and 5. So 2 times 6 times 5 to give you a total of 60 outcomes. 1 fair coin is flipped 3 consecutive times. You would get heads or tails on the first one, so that's 2 different outcomes. Heads or tails on the second one, so the 2 outcomes, times heads or tails on the third one, to give you a total of 8 outcomes. Probability of compound events. When you know the number of outcomes, you can find the probability that a compound event will occur. Find each probability. A coin is tossed and a die is rolled. So the probability of getting heads and a 6. Probability of getting heads is 1 out of 2 times the probability of getting 6 is 1 out of 6. Multiply, we get 1/12. So the probability of flipping a coin and landing on a 6 would be 1/12. B, the probability of tails in an even number. So tails is a half, 1/2. Our total possible outcomes is 6. Even, there are 3 even numbers on a die, 2, 4, 6. We can reduce the 3 6 to a half, and when we multiply, we get 1/4. So the probability of getting tails in an even number is 1/4. Your chances are better than our example A of getting heads in 6. The probability of getting tails in a 1 or 3, so tails is 1/2 times a 1/3, so that's 2/6. We can reduce the 2/6, or we could cross cancel and we get 1/3. Probability of getting tails in a 1 or a 3 is 1/6. D, the probability of heads in a number less than 4. So the probability of heads is 1/2 times a number less than 4. So that would be 1, 2, and 3. So that's 3 numbers out of 6. We can reduce the 3 6 to a half. Multiply. So your probability of getting heads in a number less than 4 is 1/4. Each spinner is spun once. The probability of getting a red and a 2. So we're using the 2 different spinners. So red on the first one and a 2 on the second one. Red on the first spinner is 1 out of 4 times the probability of getting a 2 is 1 out of 4. So your probability of getting a red and a 2 is 1/16. B says the probability of blue and an even number. So blue on the first spinner is 1/4. An even number on the second spinner is 2/4. We can reduce that down to a half. Multiply going across. We get 1/8. 3. A spinner with 8 equal sections labeled 1 through 8 is spun twice. What is the probability that it will land on 6 after the first spin and a 6 on the second spin? So we are spinning the spinner twice. So the probability of getting 6 on the first spin is 1 out of 8. Spinning again and getting a 6 again would be 1 out of 8. So the chances of getting a 6 each time is 1 out of 64.